I think up to now we have discussed Unit 1. Majority portion we have discussed from Unit 1, which consists of measures of frontal tendency and dispersion. So, whatever we have discussed in those two topics are more or less known to you. Okay, as I said you that statistics consists of problems as well as derivations also. Don't think that statistics means always consists of calculating mean, median, mode only. We are going to learn many more things apart from those. So measures of central tendency means we are going to represent one of the measure which represents the entire data with single value. Okay, measures of dispersion means it indicates deviations of the data from one another. Apart from these two, you need another measure to represent the data. So statistics is nothing but a collection of data, analysis of data and interpretation of data. So to represent the data in a better manner, in addition to measures of central tendency and dispersion, you should have one more higher order concepts which includes these moments. I think in measures of the central tendency you have learnt mean, median, mode, which are already known to you. Okay, just we have refreshed all those topics. So in measures of dispersion also some are known to you like quartiles and range. We have learnt the standard deviation. Now we are going to discuss moments which is not at all known to you. Means this is the step where you are from where you are going to learn all new topics. Okay, whatever we have discussed up to now are more or less known to you. This is the step which are completely known to you, and we are entering into the statistics with new concepts. Okay, whatever you have learned, all those are basics or all those are necessary topics for doing all these moments and further topics. Okay, from here onwards we are completely a new one. So, and from here onwards you are going to face more and more derivations also. Okay, you should be strong with mathematics. Means like simplifications using different properties of mathematics. So moments are of two types, which are nothing but non-central moments. Moments are of two types, non-central moments and central moments. Okay, the other name for non-central moments is also raw moments. Okay, moments are of two types, central moments and non-central moments. Non-central moments are also called raw moments. Generally, we indicate moments with mu. Okay, this is the letter which we pronounce as mu. I think you already knew. We call that as mu. So we have two different symbols for non-central and central. Whether it is central moments or non-central moments, all those are deviations. Deviations are nothing but differences. So let us start with non-central moments. So from here onwards, one more thing. Majority cases we are going to deal with only grouped data, not with ungrouped data. Ungrouped data is very less used. Here onwards, whatever data, obviously that represents the only grouped data. So non-central moments, the symbol which we use is mu r dash. Okay, the symbol which we use is mu r dash. You'll have this we call as dash, mu r dash. This mu r dash indicates here, this suffix stands for rth order. This we call as rth order non-central moment. Okay, mu r dash is called rth order non-central moment. So all these are nothing but deviations. Deviations are nothing but differences. 1 by n sigma fi into xi minus a whole power r, where a is nothing but any arbitrary. Arbitrary means any value chosen at random, any arbitrary value from x. Mu, there are two types of moments, central and non-central moments. Moments are represented with mu. Non-central moments are represented with mu r dash. That suffix r stands for the order. Mu r dash stands for rth order non-central moment. So we define that as 1 by n sigma fi into xi minus a whole power r. So if you put r is equal to 0 here, okay, this is about non-central moment. Just let us define, then we can go for properties. Central moments which we indicate with mu r. Mu r, r is always written as suffix. Mu r stands for rth central moment. Rth central moment, which we define as 1 by r 1 by n sigma fi into xi minus x bar whole power r. So non-central moments are nothing but deviations. Deviation means differences. Differences taken about an arbitrary point A. Mu r, central moments are nothing but deviations taken about x bar is nothing but arithmetic mean. Mu r dash is non-central moment 1 by n sigma fi xi minus a whole power r. Mu r is nothing but central moment 1 by n sigma fi into xi minus x bar whole power r. Non-central and central moments. So we have different theorems on this. Before going to those theorems, let us do a small what is mu r dash is nothing but 1 by n sigma xi minus a whole power r, arbitrary value. If you put r is equal to 0, you will get, replace r with 0. Mu 0 dash is equal to 1 by n sigma fi into xi minus a whole power 0. Anything to the power 0 is nothing but always 1. So 1 by n sigma fi. Okay. What is the relation between n and fi? N is equal to sigma fi. So we can write that as 1 by n. So mu 0 dash is always 1. What is mu 0 dash value is always 1. If you put r is equal to 1, you will get mu 1 dash is equal to 1 by n sigma fi into xi minus a whole power 1. Here you replace r with 1. So 1 by n, okay, sigma fi into, I think this you can multiply fi xi minus fi a. So 1 by n sigma, this sigma is for the first term as well as for second term, sigma fi xi, sigma fi a. As I said you that sigma always runs on a, runs on I. So you got mu 1 dash is equal to 1 by n sigma fi xi. So sigma runs on I. The second term you have fi a. A is independent of I. So you can take it out of the sigma a sigma fi. So again this 1 by n is for the both the terms, 1 by n sigma fi xi minus a sigma fi by n. As n is equal to sigma fi, those two cancels. You got, what is 1 by n sigma fi is nothing but x bar. Mu 1 dash is equal to x bar minus a. Remember this. Mu 1 dash is very important one. Mu 1 dash is x bar minus a. If you put r is equal to 2, you will get mu 2 dash is equal to, no need to simplify this, 1 by n sigma fi into xi minus a whole square. If you put r is equal to 3, you will get mu 3 dash is equal to, always up to fourth order moments are enough for us. Okay, no need to go for higher order. For mu 1 dash is first order moment, mu 2 dash is second order moment, mu 3 dash and mu 4 dash. Among those two again we have simplified mu 0 dash and mu 1 dash. Mu 0 dash is always 1, mu 1 dash is x bar minus a. That is about the non-central moments. Now let us go to central moments. That means we are going to find out the first four central moments. What is the formula for mu r central moment? 1 by n fi xi minus x bar whole power r. If you put r is equal to 0, how much you will get? Mu 0 is equal to 1 by n sigma fi into xi minus x bar whole power 0. Anything to the power 0 is 1. So you will get 1 here, 1 by n sigma fi into 1. What is sigma fi? Sigma fi is nothing but n. You will get 1 here. So mu 0 is always 1. If you put r is equal to 1, you will get mu 1 is equal to So 1 by n, okay, sigma, multiply these two terms fi xi minus fi x bar. Again this 1 by n sigma is for the first term as well as for second term. 1 by n sigma fi xi minus 1 by n sigma fi x bar. Okay, 1 by n sigma fi xi is nothing but x bar. So this x bar is independent of I. So you can take it out of the sigma x bar into 1 by n sigma fi. Sigma fi is again n. So x bar minus x bar you got, which is equal to 0. So always mu1 is 0. If you put r is equal to 2, you get mu2 is equal to 1 by n sigma fi into xi minus x bar whole square, which is nothing but variance. Am I right? Variance just now we have discussed. So from these two derivations we have again I'll repeat just one. We have two types of moments called, not very important one, because these are not only important for this semester, also entire second semester is dependent on these moments only. Non-central we'll write with mu r dash. Central we write with mu r. Its formula is 1 by n sigma fi into xi minus a whole power r. It is 1 by n sigma fi into xi minus x bar whole power r. The first four moments means mu 0 dash is 1, mu 1 dash is x bar minus a. Mu 2 means you don't have separate formula, just write as it is by putting r is equal to 2. Mu 3 dash. First two only you have the simplified expressions for those. Here mu 0 is 1, mu 1 is 0, mu 2 is 1 by n sigma fi into xi minus x bar whole square, which is always variance, because we need variance for the calculation of ST, standard deviation. Okay, these are the first four under non-central, first four under central. Always if you try shortcut one, if you have 0 here you will get 1 here, if you have 1 here you will get 0 here, that is mu 0 is 1, mu 1 is 0. Okay, if you have 0 here you will get 1 here, mu 1 is entirely different one, x bar minus 1. Try to remember this table. Okay, thank you.